Today's lesson will be talking about GCF and LCM. Now, chances are you've probably heard of these two things before. If you recall, GCF stands for greatest common factor. And if you've seen this before, typically you're finding the GCF of maybe two numbers. Today we're going to kind of advance that a little bit and take the GCF of not just numbers, but also variables. Now, we'll talk about GCF by itself first. The second line there says factors get blank than the original number. So if we look down here at the first example, we've got 10x squared y and 15x y cubed that we're going to be finding the GCF. If we want to find the greatest common factor of just say the 10 and the 15 first, would those numbers potentially get bigger, smaller, stay the same than the original? What are your thoughts? Well, if you were thinking smaller, you were on the right track. We definitely want the less than sign, but they can also be equal to. It's not going to happen for this first example, but we will find that the greatest common factor can be the same as one or potentially both of the numbers given if they're the same. The other thing we have to talk about is the variables too. So what are we going to do with the variables? We'll come back up here. I'm going to put a little star here. We need to write a note on how to deal with the variables for finding GCF. So let's scroll down and take a look at this first example. So finding the GCF of the following. Again, the 10 and the 15 we're going to look at first. So first thing I'm going to do to find GCF is I want factors. So I'm going to write 10 and 15, and then I'm just going to list them out. I prefer to list them in order because we're looking for the greatest. So if they're ordered, that'll make it easier to find. So always remember 1 and the number itself. And then what are other factors of 10? We've got 2 times 5, and that's it. 1 and 10, 2 and 5. 15, again, we got 1 and 15. 2 does not go in, so we go to 3 and 5, and that's it for 15. Now notice that they both have a 1, and they both have a 5. But our rule says the greatest common factor, so the greatest one obviously would be 5. Now, as far as the variables are concerned, so for our first one, we've got x squared. So I'm going to write this out the way we saw it in the exponents unit. And the second one has 1x, but it has 3 y's. So if we circle what they have in common, they both have an x and they both have a y. But they don't have any more. The top one has an additional x, the bottom one has an additional 2 y's, but they don't have any more in common. So the greatest common factor of the x's is 1x, and the greatest common factor of the y's is 1y. Now let's look at the exponents. Let's see if we can find a shortcut here a little bit. So we had 2 x's and 1 x, and then we had 1 y and 3 y's. Notice that in both cases we ended up with 1. So I'm going to put those exponents in just to show you. In this case, for the variables, we ended up selecting the opposite of greatest common factor. We selected the least exponent. So if we scroll back up here, let's note that in. When we're finding GCF, we can take the smallest exponent, or the least. So it's opposite of the name. So it's called the greatest common factor, but we actually take the smallest when we're dealing with the exponents. Okay, let's try another one just to get this down. So the second one is 33x to the 4th, y to the 6th, and 11x to the 5th, y to the 4th. So in this case, first and foremost, we'll write out our factors. So 1, 3, 11, and 33. And then 1 and 11, because 11 is a prime number. So note here again, there's 2 common factors, the 1 and the 11. If we want the greatest, then obviously 11 is the way to go. Now, we could write out all the variables again and kind of circle the ones they have in common, or let's use our trick. We've got x to the 4th, x to the 5th. The smaller exponent is 4. Y to the 6th and y to the 4th. The smaller exponent is also a 4. All right, and then go ahead and pause the video and try our last example here. All right, 36 and 24 have a lot in common. I'm not going to write out all of the factors here, but the largest one would be 12. And then exponent-wise, we've got c squared is the smaller one, d cubed is the smaller one, and e to the first, or just e, is the smaller one there. Now, real quick, before we move on to the LCM, what would happen here? What do you think if I got rid of this e, if that did not exist? What would that change in our final answer? So again, not the way that it's written in your notes, but let's say that that e was not in that first example. Well, if you said that the e would no longer be a part of the GCF, in this example now, again, not the original, you're right. The GCF would now be just 12c squared d to the third, because technically if there's no e there, it's technically e to the 0 power, if you recall back from exponent unit. And in this case, that means we don't have any in that one, so there's nothing in common. We don't need that in our final answer. All right, now let's switch gears and talk about LCM. So GCF was greatest common factor. LCM stands for kind of the opposite. Least common is the same, and multiple. Now, for GCF, the factors could get less than or equal to. They could get smaller or be the same. Again, the opposite. They can be greater than or equal to the original number. So they're going to be, the same number or potentially bigger. And just as we follow suit here, we'll write it out now. If we take the smallest exponent for GCF, we take the largest exponent for LCM for each variable. So if there's, the C, the D, and the E, we got to take the largest exponent of each one individually. All right, and let's take a look at a couple examples down here. Now, to find LCM, first we want to take our two numbers, and I'm going to write a list. So I'll write a 5 over here and a 4 over here, and I'm going to start multiplying. So I'll start with the smaller one. 4 is smaller, so we'll do 4 times 2 gets us 8. Let's pop back over here and advance the 5. 5 times 2 gets us 10. And I'm just going to keep going back and forth until they match. So let's go to 15 and 12. They haven't matched yet, so 16 over here would be 20. And there it is. The LCM of 4 and 5 would be 20. And again, we could write out the variables, but in this case, we already know we're just going to take the largest exponent. So x to the 4th, y to the 3rd. All right, second example, we've got 20 and 8. Definitely going to start multiplying the 8 because that's smaller than the 20. So 16 and then 24. 8 times 4 will give us 32. I think I know my multiples of 20. I'm going to keep going because those numbers aren't going to go into 20. 8 times 5 will give me 40. And look at that. There it is. 20 times 2 and 8 times 5. So 40. And then take our largest exponent. So c to the 5th and d to the 3rd. All right, go ahead and pause and try example 3 here. All right, multiplying our multiples. We've got 6 times 2 is 12, and then 18, 9, there it is, 18. Pretty quick one. And then our largest exponents, x to the 6th, y to the 5th, z to the, what do we do when they're the same? Well, that makes it easy. We don't have to decide because the largest exponent is 4. Now here again, asking that same question as we did above, what happens when one of the variables is missing? Well, the same rule applies as above. That would technically mean it's a z to the 0 power. So when we take the largest exponent, the LCM would actually still be the same because we need that z to the 4th for it to be a common multiple. All right, now if you haven't already figured it out, on your calculator, depending on what type, you'll have to search around to figure out where it is, but there is a GCF and an LCM. On some calculators, like the Casio ones we have in class, it's called GCD. But you would be able to at least find the numeric version of these. So when you go to the back of this worksheet, and you're finding LCM and GCF, if you want to use the calculator to try that, by all means, go ahead. If not, you can use the tricks that I showed you here in the beginning. So go ahead and pause at this point, and you're going to try the 6 examples of GCF and LCM on the back, and then you can jump back in to check your work. All right, so you should be jumping back on to be checking your work. So check out that top row with the LCM. And then along the bottom, note that for the GCF, this was the first example where this happened. But in this case, since the 5 and the 4 did not have any common factors, it's okay for the GCF numerically to be 1. So if you wrote a 1 here, that's also correct. It's just not needed.